Is our Earth unique? Given the immensity of the universe and its multitude of macrocosms, each more improbable than the last, it would be foolish not to dare hope that a planet comparable to our own might exist. At least from a statistical point of view. It's a question that fascinates the general public and astrophysicists alike, but there can be no definitive answer until such a discovery is made, especially as the answer depends largely on what we mean by comparable. If we limit ourselves to the size, temperature, and distance from the host star on which it depends, there would be around 6 billion Earth-like planets in the Milky Way alone. However, if we take into account other criteria, such as composition, atmosphere, magnetic field, presence of liquid water, and even the existence of life, then the number of potential candidates drops considerably. What's more, we mustn't forget that the remoteness of these planets located outside our solar system makes their observation extremely complicated, sometimes almost impossible. As exoplanets are difficult to detect, the first discovery of an object of this type only dates back to the late 1980s, alongside a dead star, a pulsar. In 1995, the discovery of 51 Pegasi b, the first exoplanet orbiting a still active star, was confirmed. Since then, the number of exoplanets discovered has grown steadily. NASA has announced that it has counted over 5,500 in the last 30 years. How would you like to meet them? Dear traveler, welcome. Today we're off on a unique journey to the strangest exoplanets in the universe. These planets, located light years from Earth, may not be as welcoming as we'd hoped, to say the least. Some are particularly incredible, even defying the laws of physics and logic. But before you set off on this fabulous expedition, if you haven't already done so, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip. Let's begin our journey with a visit to Isis, more aptly named HD 189773b. The discovery of this exoplanet dates back to 1991. The Hipparcos satellite measured its transit in front of its host star. However, its discovery was only confirmed in 2005 by a team of European astronomers. Located in the Little Fox constellation, just 63 light-years from Earth, this beautiful blue planet seems like the perfect vacation spot. But think again. Behind its beautiful, peaceful-looking azure hue, believe me, you'd better not try to land there. It's a hot, Jupiter-type exoplanet orbiting the orange dwarf star in just 2.2 days, and is therefore very close to it. Because of its relatively small distance from our Earth, it is one of the few exoplanets to have revealed its radius, approximately 1.26 times that of Jupiter, and its mass, approximately 1.15 times that of Jupiter. The clouds in its atmosphere, contrasting with its bright blue, could tempt us to make a landing and explore the planet's surface more closely. But a closer look at the atmospheric data reveals that the planet's atmosphere is far less welcoming, not to say terrifying, than we might have imagined. The winds that sweep across this gas giant blow at supersonic speeds, reaching over 7,000 kilometers per hour, or 4,400 miles per hour, more than 7 times the speed of sound. This parameter alone would propel us into an infernal spiral around the planet, with no way out. In this apocalyptic atmosphere, another phenomenon would have even more terrible consequences. Isis contains a large quantity of silicon, which diffuses this splendid bluish hue. Exposed to destructive temperatures of around 1,300 degrees Celsius, or 2,400 degrees Fahrenheit, these silicon particles condense, transforming into innumerable pieces of sharp glass. In short, this planet is far from the oasis it first appears. Quite the contrary. A deluge of mist and ice covers its surface, carried along by the cataclysmic winds that swirl relentlessly around it. Although particularly attractive, you'll understand how vital it is to keep our distance. Isis made headlines in 2007, however, when a team of astrophysicists announced that they had detected the presence of water in its bubbling atmosphere. This conclusion was based on the observation of the red spectrum of its light, passing through the atmosphere during its transit in front of the host star, using data collected by the Spitzer and Hubble telescopes. This news confirmed an idea established by theoretical planetologists, namely that gaseous exoplanets could be rich in water. While not all researchers agreed with this assertion, another Isis study did indeed show that an absorption line characteristic of the water molecule had been detected. This technique could, in future, enable scientists to detect the presence of this vital element on Earth-like exoplanets. Let's turn now to an equally inhospitable exoplanet whose remaining existence could be in serious jeopardy. It seems destined to disappear forever in an unstoppable process. Discovered in 2008 around a star similar to our own Sun, it is a very hot Jupiter in the constellation of Kocher, between 800 and 1,500 light-years from our solar system. Introducing WASP-12b. Right from the outset, this exoplanet is far less attractive than its predecessor, isn't it? Its charcoal color, for a start, is more than atypical. In fact, one study suggested that it might be a rocky, carbonaceous planet, although the existence of this type of planetary object was still only speculative. Observations by the Spitzer telescope had excited astrophysicists, showing that it contained carbon atoms in strangely high quantities. Unfortunately, this feature turned out to be wrong, as the presence of another star, relatively close to WASP-12b, distorted the results. If this exoplanet ultimately has no more carbon atoms than any other hot Jupiter, how can we explain its dark asphalt-like appearance? New observations made with the Hubble telescope have shed light on this murky peculiarity. It turns out that WASP-12b absorbs over 94% of the light produced by its star. Hot Jupiters, on the other hand, reflect an average of 40%. Against all expectations, the researchers believe that it is the very high temperatures that provide a rational explanation. Heat in excess of 2,000 degrees Celsius, or 3,600 degrees Fahrenheit, causes the molecular hydrogen present in most of Jupiter's atmosphere to dissociate into atomic hydrogen. As a result, the upper layers of this exoplanet look more like a cold star, with, like it, an extremely high rate of absorption of visible light. In the last few minutes, you've probably noticed that this exoplanet is doing a macabre dance. Although almost twice the size of our own Jupiter, this gas giant orbits so close to its parent star in just 1.1 days that the consequences are already dire. You've probably noticed its strange shape, making it look like a rugby ball. That's because it's being angrily subjected to gravitational tidal forces to such an extent that it's being deformed. But beyond this deformation and the impact of the extreme heat thrown at it by this gigantic star, WASP-12b is literally being devoured. Scientists estimate that nearly 6 billion metric tons of its mass are going up in smoke every second. On the scale of the universe, you're witnessing the final moments of this exoplanet's inescapable grip. Gradually torn apart in its death spiral, this crackling gas giant will be totally consumed in 10 million years' time, unless it suffers a terrible explosion in the meantime. One way or another, its future is, unfortunately, already mapped out. But now let's turn our attention to a much more promising planetary system. Let's set course for the constellation Aquarius, where an ultra-cold red dwarf, TRAPPIST-1, reigns over not one, but 7 exoplanets. The idea of discovering any trace of life on just one of these planets would already be extraordinary. However, in February 2017, the discovery of this planetary system, at a distance of around 39 light-years from Earth, reinforced this hope. In fact, 7 rocky planets, almost the same size and mass as our Earth, orbit this star. Their orbits are all smaller than that of Mercury with our Sun. These planets are so close together that they sometimes seem to brush against each other. Such close proximity to the host star could be cataclysmic for these planetary objects. This is an M-type star, much cooler than our Sun, with an estimated mass of 9% of the Sun's mass. Of these 7 planets, 3 are located in the habitable zone and could harbor liquid water. These are TRAPPIST-1e, 1f, and 1g, the latter being the best place of all in this habitable zone. This system is therefore one of the most studied by scientists, especially as the proximity between these 7 planets could be conducive to potential panspermia. This means that life plants would be able to circulate from one planet to another via extraterrestrial contamination. As Chandra Wickramasinghe of Buckingham University explains, in such a planetary system, the exchange of bacteriological life is almost inevitable. But let's go inside this magnificent system and take a closer look at TRAPPIST-1f, the 5th planet, this promising super-Earth that seems to have turned its gaze toward its star. As you may have noticed, due to synchronous rotation, all planets invariably present the same face to their star. But unlike the other planets, TRAPPIST-1f is not completely covered by a thick mantle of ice or volcanic oceans. Locked in, like its companions, by the tidal forces emanating from the star, it would even have a strange physiognomy, strangely resembling an eye. Most of the planet, least exposed to the red dwarf's rays, would resemble a cracked mosaic. This cold, austere world, covered in ice and plunged into perpetual darkness, would have abundant water networks flowing through countless fissures. On the other hand, the part of the planet constantly exposed to the sun would be ice-free and might even contain an ocean, albeit in a vaporous state. Under these conditions, is it legitimate to hope to find any form of life there? Because of its distance from the sun, its average equilibrium surface temperature is minus 54 degrees Celsius or minus 65 degrees Fahrenheit. Could there be a ribbon of habitability between these two zones of extreme conditions? Could there be a termination line with temperatures conducive to the existence of liquid water? In the best-case scenario, is there enough atmosphere to even out these temperature mismatches and provide conditions conducive to the emergence of life? Observations of this system with the Hubble telescope have enabled us to measure the amount of ultraviolet radiation emitted by the star. These have a considerable influence on the evolution of planets, and consequently, on the presence or absence of water on them. The closest planets could have lost abysmal quantities of water, while TRAPPIST-1F and its two neighbors would have been much less impacted. Optimism, albeit measured, is the order of the day, allowing us to imagine that the appearance of life in these distant horizons could be envisaged. As you know, many civilizations have worshipped the sun. Imagine a planet where two suns shine brightly, giving you a double sunset. In fact, this fantastic vision is reminiscent of a scene from the famous Star Wars saga. Remember Tatooine, the birthplace of the famous Skywalker, where two suns light up the sky? But let's step out of fiction and join Kepler 16b, a planet also known as circumbinary, which actually exists. Discovered in 2011 using data gathered by the Kepler Space Telescope, its existence was detected using the radial velocity method. Located in the constellation Cygnus, 245 light-years from Earth, it has no astonishing features. It is a cold gas giant, comparable to Saturn in size and mass, with a radius around 75% that of Jupiter. This planet, a priori made up of as much gas as ice mixed with rock, has an equilibrium temperature of around minus 100 degrees Celsius or minus 148 degrees Fahrenheit. It orbits in just over 228 days with a semi-major axis of around 104 million kilometers or 64 million miles from the barycenter of its two host stars. But its singularity, as you may have guessed, is due to the fact that it orbits a binary star system. The two stars orbit each other in 41 days. The more massive star is an orange dwarf of spectral type K. The second, less massive and less luminous, is a red dwarf of spectral type M. Imagine what sunsets can be like on this planet, bathed in a more or less diffuse fog. The entire sky must be adorned in orange hues, giving the impression of an infinite celestial fire. For scientists, this discovery has confirmed the existence of circumbinary planets, and thus demonstrated the astonishing diversity of celestial bodies residing within our galaxy. But even stranger still, these two stars, in their cosmic dance, take turns masking each other, thus qualifying as an algol-type eclipsing binary star. Unlike binary systems composed of relatively similar stars, these two stars are very different from each other, the red dwarf being 3 times smaller and lighter than its neighbor, the orange dwarf. When the red dwarf passes in front of the orange dwarf, it partially eclipses the latter. Conversely, the more massive and voluminous orange dwarf completely obscures its companion. During this short time, a single sun seems to pour its rays onto the planet. Because of its composition, this duo doesn't really fit with the original definition of a binary star. According to the latter, a true double star results from the union of 2 stars formed together in the same system by the laws of gravitation. Be that as it may, this flamboyant duo offers a spectacular sight when placed in our line of sight, with the planet Kepler 16b in the foreground. However, this is not the most marvelous sight a planet can offer us. Still in the constellation Cygnus, in a slightly less distant region, just 150 light-years from our Sun, a planet whose discovery was announced in 2005 presents an even more spectacular panorama. Imagine contemplating the stars alongside this one and perceiving the last fiery rays of an immense sun about to disappear behind the horizon, while 2 other stars, modest in size and much warmer in hue, still illuminate the rocky peaks of a nearby lunar satellite. Isn't it a breathtaking sight? We're close to the hot planet HD 188753AB, which, as you'll have guessed, is part of a triple star system. Until 2005, the idea that a planet could form in a gravitational system as complex as that of a triple system was merely a hypothesis. The detection of HD 188753AB would have confirmed that planets can be far more resilient under extreme conditions than scientists had previously imagined. This hot, Jupiter-type exoplanet orbits in the vicinity of 2 stars that revolve around each other in 156 days, themselves revolving around a central star in just over 25 years at a distance of around 12.3 astronomical units. As a result, these 3 suns evolve in an area so small that our own solar system couldn't fit inside them. Indeed, their living quarters are no larger than the distance separating Saturn from our Sun. Scientists previously believed that hot Jupiters came to life in thick disks of material, far from their host star, before moving closer to it on the tides. HD 188753AB, a priori 14% more massive than Jupiter, would orbit the main star in just over 3 days, exactly 80 hours. 20 times closer to the main star than our Earth is to the Sun, this exoplanet would be only 8 million kilometers or 5 million miles away from the massive star. The reason I'm using the conditional tense to describe this exoplanet is that in reality, it has never been directly observed. Its presence has been suggested by measurements of the radial velocities of the triple system. Following the announcement of its detection by Polish astrophysicist Konaki, a European team of scientists claimed to have carried out the same measurements but failed to find it. For the time being, NASA has yet to confirm its actual presence, but who knows? Perhaps the existence of such a planet will soon be confirmed in this or any other system. After all, if its presence can't yet be truly confirmed, there's nothing to suggest otherwise. Let's continue our journey. I now propose that we reach a terrifying exoplanet which seems to harbor jewels that many would dream of possessing. Let's head for the constellation of Cancer, more precisely for the system of the star 55 Cancri, more commonly known as Copernicus. This double star, some 40 light-years from Earth, is composed of a yellow dwarf similar to our Sun and a red dwarf. Above all, 5 exoplanets orbit around them, including 55 Cancri e, discovered in 2004. Let's get closer to the latter while keeping a reasonable distance. Indeed, this planet orbits at a very short distance from Copernicus, its star similar to our Sun, from which it is only 2.24 million kilometers, or 1.5 million miles away. To give you a comparison, this represents approximately 20% of the average distance between Mercury and the Sun. As you can see, this planet's surface resembles a blazing inferno. Given its proximity to its host star, it's subjected to extremely high temperatures, hence its molten volcanic surface, completely covered in incandescent lava. Take a look at its many erupting volcanoes, spewing streams of lava across its surface. Clouds of steam and gas envelop this hellish planet, whose atmosphere is particularly turbulent and chaotic. 55 Cancri e seems straight out of a science fiction universe, with extreme conditions that defy our imagination. Its surface temperature is estimated at 2,500 degrees Celsius, or 4,500 degrees Fahrenheit, and its orbital year is incredibly short, at just 18 hours. And yet, this super-Earth is very real and of great interest to scientists, not least because of its unusual composition. With a radius estimated at twice that of the Earth and a mass around 8.6 times that of the Earth, 55 Cancri e has a very high density, suggesting that it could contain a significant metallic core. Indeed, its density of around 10.9 grams per cubic centimeter is close to that of lead. Given these exceptional characteristics, an international team of scientists came up with a mind-boggling hypothesis. In 2012, these researchers suggested that 55 Cancri e might be partly composed of diamonds. This idea, preposterous at first glance, stems from the fact that its host star, unlike our Sun, contains more carbon than oxygen. As a result, large quantities of iron, silicon carbide, and carbon, such as graphite and diamond, must have been present when 55 Cancri e was formed. Based on the mass of this super-Earth, scientists have estimated that a third of it, the equivalent of 3 Earth masses, could be composed of diamond. Imagine if we could cut open this planetary object. Beneath its crimson surface of molten graphite, a thick layer of glistening diamond would be revealed, like a river of diamonds in its dark velvet case. This extravagantly concealed shell would itself encompass a layer of silicon, including other minerals, and at its center, an inner core of molten iron. Unfortunately, this treasure remains inaccessible to ordinary mortals, both because of its remoteness and the impossibility of getting close to it. Too bad, isn't it? But before we burn our wings, let's leave this inferno and go to a far more pleasant world. This is Kepler 186f, an exoplanet located in the constellation Cygnus, some 500 light-years from Earth. As you can see, this planet is much more hospitable from the outset. Apart from its sandy beige hues, it looks very much like our beautiful blue planet. Beyond its appearance, it possesses many characteristics similar to our Earth, so much so that some consider it a potentially habitable exoplanet for human beings. Its discovery, confirmed in 2014, was made possible by the extensive data collected between 2009 and 2013 by NASA's Kepler Space Telescope. Kepler 186f is the first exoplanet to be discovered with a size almost identical to Earth, orbiting in the habitable zone of its host star at a distance of 52 million kilometers. Kepler 186, a red dwarf about 500 light-years from Earth, forms a planetary system of 5 planets. All are Earth-like in size, but Kepler 186f is the only one to be found in the habitable zone, its companions being far too close to their star. While there are many planets orbiting in the habitable zone, very few meet the essential criterion of being rocky. In fact, scientists usually discover low-density megaplanets composed mainly of gas, instead of gas giants. Kepler 186f, with a radius 1.1 times that of the Earth, is very likely to be a telluric planet. If a landing were possible, we would undoubtedly discover majestic mountain ranges and oceans separating various brown continents. The Sun, half our size, would bathe us in daylight with its soft reddish rays without dazzling us. This constant mildness, due in particular to the absence of seasons, can be explained by the fact that the planet's rotation period is totally synchronized with its length of revolution, which is 130 days. Quite a nice environment, isn't it? But what is it really like? Does this planet have the necessary atmosphere to make it hospitable to our form of life? Observing this distant planet remains difficult for scientists, who for the time being can only speculate. However, their repeated simulations maintain the hope that an atmosphere compatible with liquid water is possible on Kepler 186f. What's more, the probability that it is indeed a rocky planet is sufficiently high. Could this be our second home? Before we left, I promised to surprise you throughout our journey. Now I'm offering you the chance to observe a planet straight out of the imagination of science fiction scriptwriters, a reverie that has since become reality. This is Gliese 1214b, an exoplanet sometimes nicknamed Waterworld, and with good reason. Discovered in 2009 in the Ophiuchus constellation, this is the first ocean planet to be completely covered in water. Its overall bluish hue is explained by its essentially aquatic composition. The light emanating from its host star, diffused through its dense atmosphere, is refracted by these infinite expanses of ocean, creating a soft, peaceful atmosphere. Detected by its 38-hour orbit around its host star, a red dwarf some 47 light-years from Earth, scientists were almost certain that it had an atmosphere. After studying this strange exoplanet more closely, using the James Webb Space Telescope in particular, they confirmed this hypothesis, and even concluded that it is dominated by water molecules. Unlike Neptune, this atmosphere is not made up of hydrogen and helium, but of heavy elements, in particular, water vapor particles. But this planet is even more atypical when we look at the distribution of its components. This is not a rocky planet on which sea levels have risen, as in Kevin Costner's feature film Waterworld. No, Gliese 1214b is 50% water, whereas our Earth's total mass is only 0.1%. This planet is therefore a new kind of planet, not related to either telluric or gaseous planets. This super-Earth has a diameter 2.7 times that of Earth, and a mass between 5.5 and 7.5 times greater. However, Gliese 1214b cannot support life as we know it, even if we consider only marine species. Its surface temperature is far too hot, reaching 200 degrees Celsius or 392 degrees Fahrenheit. What's more, its 200-kilometer or 125-mile thick atmospheric layer reinforces the greenhouse effect twice as much as on Earth. Finally, the enormous atmospheric pressure suffocates the planet. These extraordinary characteristics certainly shape water molecules, which agglomerate in the form of ice at high pressure. Although attractive at first glance, Gliese 1214b is a long way from offering visitors a warm welcome. But scientists don't despair. While the existence of these phantasmatic planets has been proven, researchers believe they are probably more common than previously thought. Indeed, among the thousands of planets detected of similar mass and size to this one, there could well be an ocean planet around every other star in the universe. But do you know the first exoplanet whose atmosphere was detected live by the Hubble Space Telescope? It's HD 209458b, nicknamed Osiris, an exoplanet that could almost be mistaken for a comet. Its discovery dates back to 1999, when it transited in front of its host star, a star similar to our Sun in the constellation of Pegasus, some 150 light-years from our solar system. Although Osiris could not be directly observed at the time, its presence was demonstrated by a change in the brightness of the star, HD 209458, occurring regularly every 3.5 days. Then, in 2007, the spectral lines of Osiris were observed directly using the Hubble Space Telescope. For the first time, the spectrum of an exoplanet could at last be precisely dissected. Thanks to an innovative process, NASA has declared that it is able to characterize the chemical composition of its atmosphere and consequently of many other extrasolar planets. But let's take a look at Osiris, a gas giant 200 times more massive than our Earth. With an orbit of just 3.5 days, it is evolving in close proximity to its star with disastrous consequences. Circling at speeds of over 500,000 kilometers per hour, or 310,000 miles per hour, it is subject to surface winds of up to 10,000 kilometers per hour, or 6,200 miles per hour. Barely 7 million kilometers, or 4 million miles from its star, 1/8 of the orbit separating Mercury from our Sun, its surface temperature exceeds 1,000 degrees Celsius, or 1,830 degrees Fahrenheit, on its immutably exposed face. These characteristics are at the origin of the plume it exhibits, like a comet releasing copious amounts of hydrogen. Osiris, this overheated gas giant, is living a veritable hell. Enveloped in a dense, hazy atmosphere with dominant hues of orange, red, and yellow, it's easy to make out the swirls of clouds that stretch across its surface and beyond. In this tumultuous, hellish landscape, it's easy to imagine the gigantic storms that reign here, punctuated by flashes of light, piercing this moribund atmosphere. The fact that this atmosphere includes free, even ionized oxygen and carbon atoms, right down to its outermost layers, has taken scientists by surprise. With a mass up to 10 times greater than that of hydrogen, how are they ejected from the deepest layers of the atmosphere? Hydrogen, the most abundant element in Osiris's atmosphere, is forcibly ejected by the star's heat and radiation in a stream strong enough to carry the heavier particles with it. According to astrophysicists, Osiris could be losing at least 10,000 tons of hydrogen gas every second. The planet has certainly already lost a significant part of its initial mass. Eventually, it may even be stripped of all its mass, leaving only a dense, inert crimson residue. This probable fatal outcome suggests to scientists the existence of a new planetary type. Is Osiris in the process of becoming a Chthonian planet? In other words, a rocky or metallic core of a gas giant planet whose atmosphere of helium and hydrogen has completely evaporated? This breathtaking spectacle is extremely intriguing, isn't it? In 2006, another planet was discovered with an orbit even shorter than that of Osiris. Dubbed the planet of eternal night by NASA, this is the darkest planet ever discovered orbiting a star. Meet TRES 2b, also known as Kepler 1b. This exoplanet, lurking in the Dragon constellation, 700 light-years from our Sun, looks like a coal ember on the verge of extinction. We won't attempt to enter its atmosphere, which is incapable of revealing anything other than total darkness. All the more so as it is incredibly hot, with temperatures reaching 1100 degrees Celsius or 2000 degrees Fahrenheit. The gas giant's lava-hot atmosphere is due to its proximity to the G-type yellow dwarf star, which holds it in place by gravitational force. It turns out that this exoplanet is literally red-hot by its host star, from which it is only 5 million kilometers, or 3 million miles away. It takes just 2.5 days to complete a full orbit around its sun. Despite being bathed in the fiery rays of the yellow dwarf it orbits, this hot, Jupiter-like planet seems to absorb them almost entirely. Only a faint reddish glow emanates from this dark, mysterious object. With a mass of 1.49 Jovian masses, the planet's ability to reflect light is practically nil. To explain this peculiarity, scientists carried out new measurements using the Kepler satellite to calculate its geometric albedo, or reflection rate. This proved to be the lowest ever recorded, at less than 1%. Even a simple lump of coal would reflect more light. For the researchers behind this study, published in 2011, only the beginnings of an answer are conceivable. It is well known that hot Jupiter-type objects belonging to Class 4 of Zadarsky's classification must have a bond albedo of less than 3%. This is due, on the one hand, to the absence of reflective clouds in their atmosphere, the latter being the result of the condensation of volatile compounds such as ammonia. On the other hand, the presence of alkaline metals such as sodium and potassium vapors and gaseous titanium oxide has been detected. These are highly absorbent compounds, However, these characteristics solve only part of the TRES-2b enigma. The models we have carried out all indicate that its geometric albedo is 1 or even 2 orders of magnitude below the established theoretical value. For the time being, this dark monster doesn't seem willing to tell us more. Now let's discover a planet that strangely enough contains hot ice. You heard right, we're talking about a state of water particles that doesn't fit in with what you might have learned in your first physics lessons. We're used to saying that ice, when subjected to temperatures above 0 degrees Celsius or 32 degrees Fahrenheit, is supposed to melt and turn into water, or even evaporate at higher temperatures. It turns out that an exoplanet the size of Neptune, weighing around 22 Earth masses, could well be made up mainly of an exotic form of water. To observe it, let's go to the constellation Leo, 33 light-years from our Sun. Meet Gliese 436b. Its discovery, announced in 2004, was made thanks to the Hubble Space Telescope. This exoplanet is easily recognizable in this part of the cosmos, as it too has a comet tail. Its oxygen-rich hair is almost 50 times the size of the planet, a phenomenon never before observed on such a small exoplanet. Gliese 436b orbits just 4 million kilometers, or 2.5 million miles from a red dwarf, circling its host star in 2.6 days. Its highly elliptical and consequently eccentric orbit makes it all the more interesting for astronomers studying orbital dynamics and planet-star interactions. Nevertheless, invariably exposed to its heat, this hot, comet-like Neptune is constantly boiling. Scientists estimate that it loses around 1,000 tons of gas per second, and that over its 6 billion years of existence, it has lost 10% of its atmosphere. But the planet's strangest peculiarity lies in its bowels. According to planetary atmospheric models, any cosmic object containing a mixture of hydrogen, carbon, and oxygen, when subjected to temperatures of up to 726 degrees Celsius or 1,340 degrees Fahrenheit, should also contain a significant amount of methane and a lesser concentration of carbon monoxide. Thanks to data collected by NASA's Spitzer Space Telescope, we now know that this hot planet lacks methane, despite a temperature in excess of 526 degrees Celsius or 980 degrees Fahrenheit. Researchers believe that Gliese 436b is too compact to be composed mainly of hydrogen gas, as is Jupiter. But it's probably not compact enough to resemble a rocky super-Earth. For the time being, only one deduction has been suggested. Gliese 436b is thought to be mostly made up of an exotic form of water. This would be ice hardened not by a sufficiently low temperature, but by the incredible pressure of the outer layers undergone by the particles. Nestled between a hypothetical rocky core and its gaseous envelope of hydrogen and helium, an enormous ocean of water, compressed to the point of becoming as solid as ice, would be preserved in this planet. Gliese 436b thus offers a multitude of enigmas to solve and phenomena to study, all the more so as its proximity to Earth on a cosmic scale makes it a prime target. One of the strangest planets in our universe is still in the spotlight. Discovered in 2007, this extraterrestrial planet in the constellation Libra, just 20 light-years from our Sun, could well be the future destination of adventurers eager to explore a new habitable world. Make no mistake, the planet standing before you is not our beautiful planet Earth, although it does bear a striking resemblance to it. This is Gliese 581c, one of 6 planets orbiting a red dwarf, one of which, like Gliese 581d, lies within its habitability zone. With a mass 5 times that of our Earth, it has all the essential characteristics for the potential appearance of life. In particular, its close distance to the red dwarf, which is much cooler than our Sun, gives it a surface temperature estimated at between 0 and 40 degrees Celsius, 32 and 104 degrees Fahrenheit. Gliese 581c is therefore capable of sustaining oceans of liquid water, an essential constituent for the emergence of life. But there's a downside to this exceptional discovery. If you look closely, this planet, 11 million kilometers or 7 million miles from its star, completes its orbit in just 13 days. And this configuration is not without consequences. Gliese 581c rotates synchronously with its star due to the tidal effect, which is 400 times greater than the tidal force exerted by the Moon on our Earth. This means that the planet has 2 completely different opposing faces. One of them is perpetually turned towards its Sun, while the other always faces the interstellar immensity. As a result, one part of the planet is permanently exposed to the luminous irradiation of its red dwarf, never experiencing the lull of night, and even worse, burning brightly. On the other side, the cosmic cold transforms its surface into a thick icy mantle. And yet, between these 2 sides, which endure extremely antinomic conditions, a narrow strip forms a territory where life could well emerge, and why not already exist? And this idea is far from far-fetched. In 2008, a radio signal entitled "A Message from Earth" was sent from our planet in the direction of Gliese 581c. The signal is expected to reach this intriguing and promising blue planet around the year 2029. I leave it to you to imagine the amazement, infatuation, or fright this signal could provoke, should we receive a response in return in a few decades' time, or even a visit from extraterrestrials. This is reminiscent of the scenario in Battleship, a 2012 science fiction film in which aliens from Gliese 581c attack Earth after receiving one of our messages. In the end, lingering around this other blue planet might not be the best thing to do. You're probably wondering about it too. Too much curiosity could well cut us off from a protective critical spirit. But let's leave this glittering land of welcome behind us. Illusory for the moment, it nevertheless holds out hope for the future discovery of a world equivalent to our Earth. All the more so, as the discoveries made in recent years have continued to shake us to our foundations. One of them concerns a gas giant discovered in 2009, whose properties continue to boggle the mind. Introducing WASP-17b, a hot Jupiter-like exoplanet whose dimensions at the time of its detection proved incredible. Located in the Scorpio constellation, over 1,300 light-years from the Sun, this gas giant orbits an F-type star. While its mass is almost 80% that of Jupiter, its radius is 1.5 to 2 times that of Jupiter, the largest planet in our solar system. For scientists, this discovery has once again broken the law concerning the sizes that can be reached by such an object in our universe. In theory, WASP-17b shouldn't exist. The unusual dimensions of this planet remain a mystery, unable to be explained by established models of planetary evolution. This gas giant is so swollen that its density, estimated at 0.17 grams per cubic centimeter, is only 13% that of Jupiter, or 70 times less than that of our planet Earth. By comparison, WASP-17b is less compact than a marshmallow with a density of 0.21 grams per cubic centimeter. As a result, this exoplanet is one of the lightest objects of its type ever discovered. What's more, with a radius of around 130,000 kilometers or 80,000 miles, this gigantic cosmic marshmallow completes a full rotation in just 3.7 days around its sun, only 7.7 million kilometers or 5 million miles away. But even more surprisingly, this planet behaves in a totally unexpected way, displaying a retrograde and a priori eccentric orbit. This means that it rotates in the opposite direction to its neighboring star. This configuration is probably at the origin of its unusually low density, as the planet is subject to strong tidal effects. Even more mind-boggling, data captured on March 12th and 13th, 2023 by the MIRI instrument on the James Webb Space Telescope, a cutting-edge piece of mid-infrared equipment, led to an unimaginable discovery. Researchers have announced the first ever detection of quartz nanocrystals in clouds in the upper atmosphere of WASP-17b. Silicates have already been detected in the atmospheres of other exoplanets. But this is the first time that a discovery of silicates composed solely of quartz has been detected in such an environment. This discovery was made possible by the planet's very short orbital period. This facilitated the study of transmission spectrography, a technique that measures how starlight is scattered and filtered as it passes through the atmosphere of an exoplanet. This exoplanet, with its increasingly incredible properties, has been the subject of another discovery, just as improbable as ever. Using high-resolution spectroscopy, a new team of scientists reported in August 2023 that they had detected another molecule in the atmosphere of WASP-17b. This is the first time that such a molecule, usually detected in stars, has been found in a planetary atmosphere. The molecule in question is chromium hydride, a metallic chemical compound nicknamed the thermometer molecule. This extremely rare metal hydride is singularly abundant in a temperature range between 930 and 1730 degrees Celsius, or 1700 and 3150 degrees Fahrenheit. Through these discoveries, scientists hope to gain further insight into the formation and evolution of this planet, but also of others. Now that they know that such molecules can be found in the atmospheres of similar objects, they will be able to focus their research even more precisely. It's a valuable opportunity for them to deepen their understanding of exoplanets and the processes that govern their atmosphere, formation, and evolution. Let's move on to another Jupiter-like gas giant and find out why this one intrigues astrophysicists so much. Named HD 106906b, this exoplanet, 11 times more massive than Jupiter, was detected around 336 light-years from our Sun in the Southern Cross constellation. This exoplanet stands out for its very strange orbital properties, and with good reason. It takes almost 15,000 years to complete one revolution around its host star, a pair of stars made up of two F-type yellow-white dwarfs. When its discovery was announced in 2013, scientists declared it a great first. No other planet has ever been detected so far from its central star, its distance having been estimated at over 730 astronomical units, or practically 68 billion kilometers, or 42 billion miles. To calculate this orbit, astronomers were able to draw on 14 years of data collected by the Hubble Space Telescope. This extraordinarily precise data enabled scientists to prove the unusual motion of a gas giant. It moves with unprecedented slowness due to the weak gravitational attraction between it and its host stars. Even more surprising, this exoplanet follows a relatively elongated orbit, but more importantly is located outside the debris disk surrounding its parent star, unlike most exosolar planets of the same type. What's more, this disk appears to be undergoing significant gravitational interactions, and is also showing itself in a particularly unusual shape, not circular, but stretched and asymmetrical. The question now is how such a planet could have ended up so far from its main star, and what's more, outside the disk. Astrophysicists initially suggested that the planet had indeed formed inside the debris disk, but that the strong gravitational interactions had then ejected it into interstellar space. A nearby star would in turn have allowed this gas giant to stabilize its atypical orbit, preventing it from drifting forever into the cosmos. However, this theory has been called into question by other researchers who have developed a model to track the orbital trajectory of HD 106906b, and above all, to determine its impact on the debris disk. While no other planets have been detected in this planetary system, the orbit of the one studied alone is sufficient to explain the shape of the disk. What's more, this new study calls into question where this exoplanet formed. According to the scientists, the model shows that it probably formed not inside, but outside the disk. If this were not the case, and still according to their model, the shape of the disk would be very different from what we can observe today. Still, the enigma remains unsolved. Could it be that neighboring stars have destabilized the planet during their migration, causing the planet in turn to disrupt the disk? Conversely, could the host stars of this binary system have caused disturbances to the planet, subsequently distorting the disk? Or could neighboring stars during a close passage have simultaneously disturbed the planet and the disk? I'd now like to take you to the constellation of Centauri, where you'll be in for another surprise. Located 430 light-years from Earth, an orange-colored star in the pre-main sequence, whose mass and size are similar to those of the Sun, has a most extravagant planet as its companion. Meet J1407b and its celestial jewels, spread out like no other in this starry cosmos, discovered in 2012. As you can see, it boasts dozens of rings, whose impressive size is enough to make our beautiful Saturn swoon, their diameter reaching 120 million kilometers, or 75 million miles. In comparison, Saturn's rings are 200 times larger, equivalent to the surface of several full moons in our night sky. According to astronomers, there appear to be more than 30 of them, each harboring innumerable grains of cosmic dust, and perhaps even good-sized lumps of matter. Once again, this astonishing discovery was made by chance. During an exoplanet search program, the star of this planetary system attracted attention for its behavior. During nearly 2 months of observation, its light curve showed particularly anarchic and rapid fluctuations, ranging from a few tens of minutes to several hours. Faced with this phenomenon, only one explanation emerged. The star is eclipsed by a system of rings, the latter displaying a wide range of dimensions. What kind of exoplanet could possibly have such attributes? It's probably a super Saturn in its infancy. The rings contain a lot of matter in the form of dust, which is likely to gradually coalesce into satellites orbiting the planet. In fact, one of these hypothetical satellites is probably in the process of forming, as evidenced by the existence of a gap within this enormous structure. This apparent gap between two disks can plausibly be explained by the formation of a satellite in this portion, which has agglomerated most of the matter present here. According to their estimates, this exoloon could have a mass somewhere between that of the Earth and Mars, and would take 2 years to complete a full revolution around J1407b. For astrophysicists, this process is only just beginning. In several million years' time, after having thinned considerably, these rings will eventually disappear forever, leaving in their place several satellites orbiting this super Saturn. But for now, we can still enjoy the grandiose spectacle offered by these gigantic rings. Our journey now takes us close to an exoplanet that seems to rival most stars. We'll take a step back, as its temperatures are extremely hot. In fact, it's hotter than at least 80% of the stars in our universe. Back in the Cygnus constellation, 650 light-years from Earth, here's Kelt 9b. Discovered in 2017, this strange planet with an atmosphere unlike any other is the hottest ever detected. An ultra-hot Jupiter, it orbits its star, itself known for its more than strange properties. Almost twice the size of the Sun, this star is also one of the hottest known to date. You're looking at one of the most extraordinary duos in the universe. This host star reaches insane temperatures, approaching 9,900 degrees Celsius or 18,000 degrees Fahrenheit. As a reminder, our Sun, whose fiery rays are already enough to wreak havoc, doesn't exceed 5,500 degrees Celsius or 10,000 degrees Fahrenheit in surface temperature. But that's not all. This blue giant star rotates so fast that its appearance is distorted, with flattened poles and a singularly enlarged equatorial zone. In fact, its flattened spheroidal shape has repercussions for its companion planet. Although Kelt 9b experiences unprecedented temperatures, being some 30 times closer to its star than the Earth is to the Sun, it does have seasons. Take a look at this magnificent gas giant. Almost twice as large as Jupiter, its mass is estimated at almost 3 Jovian masses. Exceptionally close to its host star, it receives 44,000 times more energy than we do from the Sun. As you can see, this colossal exoplanet orbits rapidly. Its complete revolution takes just 36 hours. Rather short for a year, isn't it? Its orbit follows a trajectory that passes just above the star's two poles. So when Kelt 9b is near one of them, it passes through an extremely hot zone. But when it faces the star's swollen equator, it benefits from a certain cooling. This strange planet thus experiences 2 warm seasons and 2 winter seasons, so to speak, at regular intervals every 36 hours. On the other hand, due to its proximity to the star, the planet is locked onto the latter's gravitational tides, immutably showing the same face to this blazing sun. If Kelt 9b hadn't been so massive, its atmosphere would have evaporated long ago under the effect of the ultraviolet radiation produced by the star. Like Mercury, it would already resemble a small rocky desert core. Nevertheless, this scenario could well unfold at any moment. For the time being, however, its vaporous envelope is undergoing the wrath of this unusual star. Kelt 9b's atmosphere is continuously plowed by its parent star to the point where it resembles no other planetary atmosphere, as attested by a study published in 2018 in the journal Nature. The abundant hydrogen molecules are literally torn apart when exposed to the star's fierce forces. Then, when they reach the planet's dark side, they recompose. Then, when they again come into contact with the star's light, the process starts all over again. Analysis of this atmosphere has also enabled scientists to detect iron and titanium atoms, which cannot combine with other atoms due to the intense heat. Kelt 9b is therefore one of the first planets to detect iron in its atomic form. Iron, though abundant in the universe, is usually combined with other molecules when identified in the vicinity of any solid cosmic form. Once again, this atypical planet is a formidable field of exploration for astrophysicists. Future observations will enable us to study in greater detail the boundary that separates the two sides of this exoplanet. And who knows, could water molecules be present? When we think of luminous objects in the night sky, we usually think of the many stars. However, all kinds of celestial bodies are also capable of shining. Such is the case of an exoplanet discovered in 2020 by NASA's TESS satellite. This is LTT 9779b, the brightest exoplanet ever detected by astronomers outside our solar system, with a brilliance similar to that of Venus. Located more than 260 years from our Sun in the constellation of the Sculptor, this exoplanet is of the hot Neptune type. Its radius is around 5 times that of the Earth, while its mass is 29 times greater. With an orbital period of just 17 hours, it is one of the few planets recorded in the hot Neptune desert. Given its proximity to its host star, it's no surprise that scientists have recorded extremely high surface temperatures, reaching over 2,000 degrees Celsius or 3,600 degrees Fahrenheit on its illuminated side. Astrophysicists have estimated that this strange planet is able to reflect 80% of the light emitted by its host star. But how is this planet able to behave like a reflecting mirror, and precisely in this configuration? Because of the extreme heat, no clouds are expected to form on the surface of such an object. And yet, it would seem that clouds are the reason LTT 9779b looks the way it does. Until now, only gas giants 10 times larger than our Earth, or modest rocky planets half their size, have been detected with orbits of less than 24 hours. But this exoplanet is about 5 times the size of our Earth. Its existence alone is already a mystery. What's more, given its proximity to its host star, any trace of atmosphere seems unthinkable. The latter should have been torn off long ago. For scientists, there is only one possible explanation. The planet's atmosphere is saturated with silicate vapors, the material found in glass, and metal vapors vaporized by the intense heat. In short, metallic clouds envelop the planet. Like a shield, they are incredibly reflective, giving it an extraordinary mirror-like appearance and preserving its atmosphere. The detection of such a planet represents a major breakthrough for the scientific community. In particular, it provides proof that an object the size of Neptune can survive in such an unseemly environment. But what happens when the star of a planetary system dies? What happens to the planets as their host star declines to the white dwarf stage? While the inner planets are probably absorbed during the red giant phase, do the outer gas giant planets manage to survive? This question is far from trivial, for what will become of our own planetary system when our sun reaches this stage? A team of astronomers recently found the answer. After pointing the sensors of the James Webb Space Telescope at various white dwarfs, the scientists succeeded in detecting 2 massive exoplanets. Each of these 2 planets orbits a dead star, both at distances similar to those of the gas giants in our solar system. These 2 exoplanets, named WD 1202-232 and WD 2105-82, have masses estimated at 1 and 7 times that of Jupiter. Respectively, 5.3 and 1.6 billion years old, these gas giants orbit at 11.5 AU for the former and 34.6 AU for the latter. This configuration is ideal for scientists. The 2 exoplanets bear a striking resemblance to Jupiter and Saturn respectively. What's more, our sun in a few billion years' time should resemble this white dwarf. Better than divination, this discovery is capable of showing us what our own system will probably look like when the time comes for our sun to slumber for eternity. Before turning into a white dwarf, our star will most likely annihilate the planets in its inner system, including our beautiful Earth. On the other hand, gas giants like these 2 exoplanets are likely to survive the cosmic upheaval. Our journey is coming to an end. We're about to return to terra firma, topped by a more forgiving sky where the weather, though sometimes capricious and devastating, remains most clement. Through the worlds we've just visited, each more fascinating and intriguing than the last, you've been able to observe the diversity and richness of the universe that surrounds us. While the cosmos abounds in systems with extraordinary properties, few are thoughtful enough to support any form of life. However, one recently discovered exoplanet, located just 137 light-years away, is proving to be very promising. This is the exoplanet TOI 715b, whose discovery was announced in January 2024 by NASA. This super-Earth evolves in the so-called conservative habitable zone around its star, a red dwarf, alongside a second, even larger planet, whose existence has yet to be confirmed. While the presence of liquid water on its surface is conceivable, thanks to ideal temperatures, the other criteria essential for life are still being studied. This exoplanet, which receives the equivalent of 86% of the light we receive from the Sun, could well be covered with oceans and continents. Clouds similar to our own are also conceivable. Of course, no one can say whether it is actually habitable, or whether it already harbors even a single form of life. But this possibility is a beacon of hope, driving researchers ever onward to explore the cosmos. Who knows what the future holds? Perhaps one day we'll be able to make contact with other civilizations from an unknown world. And why not finally tread the soil of extraordinary exoplanets?